Hello students and good morning. In this video, we are going to cover the practice set 5.3 based on the formula of a slope or the slope formula of coordinate geometry chapter class 10. So we will start from the last problem. So the last problem is problem number 8. Find K if PQ parallel RS and PQR and S are given. So we have two lines PQ and RS are parallel and we have to find the value of K. So let's find the value of K. Okay. So it is given that PQ is parallel to RS. Then point P's coordinates are 2, 4. Point Q is with the coordinates 3, 6. Point R's coordinate are 3, 1 and point S coordinates are 5, K. These things are given. Since these two lines are parallel, meaning slope of these two lines are equal. Therefore, slope of PQ must be equal to slope of RS. Therefore, using slope formula, okay, slope of PQ must be equal to 6 minus 4 over 3 minus 2, that is y2 minus y1 upon x2 minus x1. So we have the first point in line PQ is P and the second point is Q. That is why 6 minus 4, that is y2 minus y1 divided by 3 minus 2, that is x2 minus x1. Similarly to the right side, slope of RS must be equal to K minus 1 upon 5 minus 3. Therefore, 6 minus 4 is 2 and 3 minus 2 is 1 equals to K minus 1 will remain as it is and 5 minus 3 equals to 2. Now perform the cross multiplication operation. Therefore, K minus 1 times 1 is K minus 1 and 2 times 2 is 4. Therefore, K equals to 4 plus 1. Therefore, K is equal to 5. Okay, this is the way we can find the value of K in this problem. Let's find another solution of another problem. So here it is problem number 7 from the same practice set. Find K if B and C points on line BC are given and line BC's slope is 7. So let's write whatever is given. Slope of line BC is 7 and B's coordinates are K, minus 5 and C's coordinates are 1, 2. These things are given. Therefore, using slope formula, slope of line BC must be equal to y2 minus y1 upon x2 minus x1, that is 2 minus 5 upon x2 minus x1 means 1 minus k. and slope of the line BC is given as 7. So replace 7, replace slope of line BC with the number 7 equals to 5 minus 5 will become positive 7 upon 1 minus k. Now perform the cross multiplication operation. Therefore, 7 ones are 7, right? 1 times 7 is 7. 7 times 1 is 7. And 7 times minus k is minus 7k. Therefore, 7 minus 7 equals to minus 7k. Then 7 minus 7 is 0 equals to minus 7k. Therefore, simply k is equal to 0, and that's it. Now let's solve problem number 6. Find k if r's coordinates are 1, minus 1 and s coordinates are minus 2, k, and slope of line rs is given as minus 2. So let's write whatever is given. Slope of line rs is minus 2 and coordinates of r are 1, minus 1 and the same for s are minus 2, k. So it is given. Therefore, using slope formula, slope of line rs must be equal to y2 minus y1 upon x2 minus x1, that is k minus 1 upon x2 minus x1, meaning minus 2 minus 1. Okay, since the slope of line rs equals to minus 2, just replace this minus 2 for slope of line rs, that is minus 2 equals to, now k minus 1 will give us k plus 1 upon minus 2 minus 1 equals to minus 3. Now perform the cross multiplication operation. Therefore, k plus 1 equals to minus 2 times minus 3 will give us positive 6. Therefore, k must be equal to 6 minus 1, that is k equals to positive 5, and that's the value of k. Now let's move towards the previous problem, that is problem number 5 for the same practice set. Problem number 5 states that show that A, B, C, and D are the vertices of a parallelogram. Means joining points A, B, C, and D, we will get a quadrilateral, and we have to show that the quadrilateral is parallelogram. So we must recall the definition of a parallelogram. That is, if opposite sides both pair are parallel, then the quadrilateral is parallelogram. And using slope formula, we have to show or prove that the slopes of opposite sides are equal. Then the opposite sides will become parallel, and that will satisfy the condition for the definition of parallelogram. So let's write whatever given. A's coordinates are minus 4, minus 7. B's coordinates are minus 1, 2. C's coordinates are 8, 5. And point D's coordinates are 5, minus 4. So these 4 points with their respective coordinates are given. Therefore, using slope formula, first let's draw a raw figure or the rough figure here. So it will become convenient to find the slopes of opposite sides. So let us consider that we have point A is here, then B, C, and D. So first let's find the slope of line BC or side, AB. Slope of AB equals to A and B. So we have first point A for line AB and second one is point B. So the slope for the slope formula, we will write that 2 minus minus 7, 2 minus minus 7, that is y2 minus y1, and in the denominator we will write minus 1 minus minus 4, that is x2 minus x1, minus 1 minus minus 4. It will give us 2 plus 7 upon minus 1 plus 4, and that is 9 upon 3, meaning 3. Therefore, the slope of line AB is 3. So we will give statement number 1. Now, slope of the opposite side of AB, that is CD. So slope of CD, from the formula we will write minus 4 minus 5 divided by 5 minus 8. And this will give us the value minus 9 upon minus 3. Now minus minus will become plus in the division operation, and the whole value of this statement will equal to positive 3. Therefore, the slope of line CD equals to 3. So we will give it number 2. So from statement number 1 and 2, we can find that slope of AB is equal to slope of CD. Therefore, from statement number 1 and 2, we can write that slope of AB equals to slope of CD. And we know that if slopes of two distinct lines are equal, then those lines are parallel. So we have seen this in yesterday's lecture. Therefore, we can write AB is parallel to CD, and this will our statement number 3. Now, by the same way, we have to find the slope of AD and BC, and they must be equal if these are the vertices of parallelogram. So let's find the slopes of those sides. Now, slope of AD is equal to, now we have point A is here and D is here. So slope of AD must be equal to minus 4 minus minus 7 upon 5 minus minus 4. All right. So this minus into minus will become plus. So this negative 7 will become the positive 7. So 7 minus 4 will give us positive 3, and minus into minus 4 will give us positive 4, and 5 plus 4 will give positive 9. Therefore, the slope of AD must be equal to 1 upon 3, and this will be our statement number 4. By the same way, we will find the slope of BC, and slope of BC is equal to, now let's find where these points are, B and C. For the slope of BC, we will write 5 minus 2, that is y2 minus y1, 5 minus 2 upon 8 minus minus 1, 8 minus minus 1, and this fraction must be equal to positive 3 upon positive 9, which will be equal to 1 upon 3. And now 1 upon 3 is the slope of BC, and this will be our statement number 5. Now from statement number 4 and 5, we can write the slope of AD is equal to slope of BC. Therefore, slope of AD is equal to slope of BC from statement number 4 and 5. Since the slopes of these two distinct lines are equal, therefore these two lines must be parallel. Therefore, AD is parallel to BC. This will be our statement number 6. Now check out statement number 3 and 6. We have the pairs of opposite sides of this quadrilateral ABCD are parallel. Therefore, from the definition, this quadrilateral must be a parallelogram. Therefore, quadrilateral ABCD is a parallelogram, and we will write the reason as from statement number 3 and 6. Since ABCD is a parallelogram, therefore points A, B, C, and D are the vertices of a parallelogram. Hence, it is proved. And that's it. Now let's solve problem number 4. So here we have problem number 4, which states if A, B, and C are the vertices of a triangle, then find the slope of each side. Simply we have to find the slope of each side using slope formula. And one thing we must remember, that since these three vertices are the vertices of a triangle, means whatever the side will form, they will intersect each other. Since they are intersect each other, means AB, BC, and AC will intersect each other, one another. Therefore, they are not parallel. Since they are not parallel, so slope of each individual side will different, and the slope of none of the side will same, right? So the slopes of all these sides are different. Point A, whose coordinates are 1, -1, B's coordinates are 0, 4, and C's coordinates are -5, 3. So these things are given. Therefore, using slope formula, slope of AB, let's find slope of AB first. So the slope of AB must be equal to 4 minus -1 upon 0 minus 1. And it will be equal to positive 5 upon -1, which is equal to -5. So the slope of AB, or side AB, equals to -5. Now, slope of BC. Now the point B is our first point for the slope of BC and C will the second point. So the slope of BC is equal to 3 minus 4 upon minus 4 minus 5 minus 0. And it will give us minus 1 upon minus 5, and that is equal to 1 upon 5. So the slope of BC equals to 1 upon 5. Now the last thing, or the last slope, or the slope of last line, or the slope of last side, that is slope of AC equals to 3 minus minus 1 upon minus 5 minus 1. Minus 5 minus 1, which is equal to positive 4, negative 6. So 2 2s are 4 and 2 3s are 6, and this negative sign will be go to the numerator since it is a standard form of rational number. So the slope of AC is equal to minus 2 upon 3, and we can clearly see that no slope is equal since these are the sides of a triangle and they are not parallel, or not a single side of any triangle is parallel to other line. That is why slopes of each sides is different here. Therefore, slopes of each side of triangle ABC are as we found here. And that's it. Now let's move towards the problem number 3. So here is problem number 3, which states determine whether the following points are collinear. So we have to find whether these 3 points in each problem are parallel or not. For that, we will find the slope of each segment which will form from these 3 points. Not each, in fact, we have to find the slope of any 2 segments that will be formed from these 3 points. And if the slopes of those 2 segments or 2 lines are equal, then those 3 points are collinear, or they are not collinear if we do not find the slope of any 2 lines equal. Okay, so let's find the slope of AB and BC in problem number or sub problem number 1. Let's write the given points. A, whose coordinates are -1, -1, B's coordinates are 0, 1, and C's coordinates are 1, 3. Therefore, using slope formula, slope of AB must be equal to 1 minus -1, 1 minus -1 upon 0 minus -1, 0 minus -1, which will give us positive 2 upon positive 1. Therefore, the slope of AB is positive 2. And we will write number 1, and this will become our statement number 1. And now let's find the slope of either BC or AC. So I'm going to find the slope of BC here. and slope of BC must be equal to 3 minus 1 upon 1 minus 0. 1 minus 0, that will be equal to 2 upon 1, which is again equal to positive 2, and this will be our statement number 2. Therefore, from statement number 1 and 2, we can say that the slope of AB is equal to slope of BC, since the right sides of these statements showing the same number. So left hand sides are also same. Therefore, from 1 and 2, slope of AB is equal to slope of BC, since the slopes of two segments formed by these 3 points are equal, they must be collinear. Therefore, points A, B and C are collinear. And if the slopes of these two or any two segments of three segments slope not equal, then those 3 points are not collinear or they are non-collinear. By the same way, you can find the slopes or whether the given 3 points in each sub-problem are collinear or not. Now, I'm going to solve problem number 2. So, remaining problems are homework for you. The problem number 2 is saying that find the slope of the lines passing through the given points. So simply we have to find the slopes of lines which are passing through given 2 points, which we already have practiced in these examples. So I'm not going to take these problems in main problem number 2. So I'm just taking problem number 1 straightforward. Problem number 1, angles made by the line with the positive direction of x-axis are given. Find the slope of these lines. So we have the angles which are made between a line and x-axis, and we have to find the slope of each line which are making or forming these angles to the positive direction of x-axis. Now let's see how to solve these kinds of problems. Problem number 1, theta equals to 45 degree. Okay, so we are going to consider that the angle made by the line to the positive direction of x-axis equals to theta, and since the 45 degree is given, so the value of theta for first problem will become 45 degree. Therefore, slope of the line, that is m, equals to tan theta, that is tan 45 degree. Therefore, slope is equal to, and the value of tan 45. So value of tan 45 is always equal to 1. Therefore, slope of the first line is equal to 1, right? Now, problem number 2, the theta is equal to 60 degree. Therefore, slope of that particular line must be equal to tan theta, that is tan 60 degree, and we know the value of tan 60 is root 3. Therefore, slope of that particular line is root 3. So these are the short answer type questions. And for the last, theta is equal to 90 degree. Therefore, slope of that line equals to tan theta, that is tan 90 degree, and we know the value of tan 90, which is undefined, means this line who is making the angle of 90 degree with the x-axis must be y-axis or any line parallel to y-axis whose slope is always undefined. Since the value of tan 90 is undefined, therefore slope is undefined, or we can write therefore slope of the line is undefined. Okay, so that's all for today. If you like this video, please hit the like button, and thanks for watching this video. Have a great time. Bye bye.